serving the U.S. state and local government area in the Northeast. As Steve mentioned, we did an Azure Infrastructure as a Service two-day workshop in Cambridge, Massachusetts last week with a bunch of customers, and we were showing people how to use and leverage in a hands-on format, how to use and leverage Azure for infrastructure service, how to migrate virtual machines, how to fire them up, and how to architect their Azure infrastructure appropriately. And the last hour or two of the second day, I covered Azure Site Recovery and how it worked and how people are using it to migrate. And that's why Steve wanted me to chat today. If you have any questions after the fact, please feel free to just email me. My email address is johnkel@microsoft.com. And just for the record, the person in the picture is not actually me. So the agenda, we're going to have a quick, brief orientation and overview into Azure and the size and scale and why you might want to leverage Azure as a public cloud infrastructure for disaster recovery and business continuity. I'll then walk you through some of the components of ASR and then actually show you my Azure Site Recovery infrastructure that I leverage from my house and the various servers I have at my house, a couple of VMware boxes, Hyper-V and other, that I replicate into our Azure East data center, and then just go over a few links and things with you so you could try this on your own or just discuss it further amongst yourselves. To provide a little bit of context, it's worth understanding that Microsoft's cloud isn't just Office 365 and isn't just Azure. We actually offer a bunch of different capabilities in our broad portfolio of cloud offerings. Office 365, of course, being kind of the productivity bellwether of that and representing a good chunk of what Microsoft has invested in the cloud. But we also offer things like business applications, security and management for monitoring your on-premises data center infrastructure and mobile devices and managing all those things, and managing identities, multi-factor authentication, those sorts of things, as well as data intelligence through our Cortana Analytics Suite and Azure, which is really what we're going to talk about today, where a lot of our other application services and the Lego building blocks of IT infrastructure really live. Wanted to provide you a little bit of context and scale perspective on Azure. Azure, or Microsoft's cloud infrastructure, is what's classified as a hyperscale infrastructure. There are 3 hyperscale the event of a disaster, provide those fundamental services like secure networking between where your server workloads are running and other components of your infrastructure. That's an important thought, and that's one of those things that we deal with from an Azure perspective very effectively. Also, how are you going to get all of your compute online as quickly as possible? Sometimes when there's a disaster and you need to recover, you may not have sufficient hardware. Again, I mentioned Microsoft is a hyperscale cloud provider. We've got all that already in our data centers ready for you to use. The other piece is storage. Where on earth can you get an economical amount of storage to keep all of the records, the video, and other pieces online, and how will you get access to it from a compute perspective, network perspective, and more importantly, how will you give your users secure, high-performance access into that infrastructure? All of these things mean that essentially your DR infrastructure is going to be expensive to run potentially. Now, you'll also need automation to make these workloads fail over. When you have a disaster recovery, there's usually a recovery plan, which is a white binder that's sitting somewhere in your data center with a bunch of coffee rings on it that's immediately out of date once it's written. How will you use the manual processes or hopefully automate those processes to create the failover successfully so that your services will come online? Well, ultimately, we've automated all that in Azure for you. So, why is Azure a good solution for that? Again, I mentioned we've got monitoring in Azure through a variety of mechanisms that we have. We need to monitor Azure very effectively. A lot of what we've got running in Windows or in Azure is running on Windows. A lot of what you have is Windows. Some of it's Linux. Those same monitoring tools that you have will be available to you there. Networking, as I mentioned, we've got one of the largest fiber networks in the world. Plus, we provide you options to network into it. We've got a lot of compute. We've got a lot of storage. And we've licked the whole replication and automation piece, and I'll show you that in a little bit. We actually present a very comprehensive platform around networking, compute, storage, protection, and client services with our networking and automation to let your workloads fail very effectively into our data center and essentially fail back to yours if you need to. And I'll just let all these little arrows continue to build. So, look at all the happy applications and all the great things happening. So why should you select Azure? Again, we have great cloud scale. We're super efficient. We offer block-level storage in our data centers that scales performance-wise much higher than a storage area network would. It's interesting to note that within Azure, because of the scale of what we have, we don't actually use storage area networks because they can't perform at the level required in a hyperscale cloud infrastructure. So we can actually provide orders of magnitude greater storage performance across the aggregate infrastructure than we can than any SAN on Earth. We also then, because of the way we provision via a secure software-defined infrastructure, we give you ultimate control over your infrastructure. You have the keys to the kingdom as far as firing up VMs, defining secure networking, doing site-to-site VPNs or those express route connections as you want to. It's also worth noting that Microsoft has embraced open source. We're very much a multi-platform company. 40%-ish of the virtual machines we run in Azure are running open source software, running various editions of Linux, and I'll show you a little bit more about that in a little bit. And again, it is secure. The levels of certification that we have in Azure are better than, and the certifications and government certification process that we go through is more rigorous than any other hyperscale cloud provider. It's worth noting that in our government Azure cloud infrastructure, if that's where you're going to fail into, we also have CGIS and IRS 1075 compliant deployment modalities for you so that you can deploy in such a way to do that. And half the states in the country have signed CGIS amendments with Microsoft with regard to the storage and use of criminal justice information system data within Azure. And ultimately, everything's simpler. So now I'm going to get into the nuts and bolts of Azure and Azure Site Recovery. Azure Site Recovery is a brand name for a group of technologies that Microsoft offers to allow you to replicate virtual machines into Azure or between different sites within your infrastructure. The first part of it that I want to mention is Hyper-V to Hyper-V replication. While many customers are very much VMware-centric, one of the things Microsoft recognized, and we actually did it again, I mentioned a hurricane before Hurricane Sandy. The hurricane that devastated New Orleans, Microsoft engineers were watching it in the ocean come towards New Orleans. And we all watched it on the news for a week. And then ultimately it devastated New Orleans. People's data centers were washed out. They lost data because they couldn't effectively move data out of that data center, out of the region or out of the data center. As part of that, Microsoft designed in asynchronous replication, built it right into our hypervisor so that people could replicate virtual machines from one Hyper-V installation to another Hyper-V installation anywhere in the world. And we built it in, and it's a free service that's part of Hyper-V architecture. So that was one of the first components we activated that allows you to replicate virtual machines into Azure or between Hyper-V sites. But what we did recognize was that many of our customers in North America in particular relied on VMware, and that Hyper-V to Hyper-V replication wasn't necessarily an option because they weren't leveraging Hyper-V. About 2.5 years ago, we acquired the technology assets of a company called InMaj, which had been in market for, more than 10 years, providing asynchronous replication of physical workloads or VMware workloads between different sites. So what their software did, InMaj Scout, was allowed for the installation of a lightweight agent either in a physical x86 workload or a virtual machine running on VMware, would discover the VMware infrastructure and allow for the replication of those workloads to another VMware host. So you could take and replicate a physical VM, a physical server, or a VMware-based VM to another VMware infrastructure and be able to turn it on. A lot more flexible than some of the technologies you might see from folks like VMware, because they don't really support replication from physical box to VMware. But we do that, and we do it with very low downtime because, again, it's asynchronous replication using an agented format. Microsoft acquired this technology because we realized that customers didn't want to invest in an expensive Site B infrastructure. So what did we do? Well, we took this technology and we leveraged the capability to replicate from VMware and physical and enhanced it to allow for the replication of those workloads directly into Azure. We, of course, already had Hyper-V replication, so that was relatively easy. Microsoft, as part of what we have in this ASR suite of technologies, allows and enables the inexpensive replication of VMs, physical VMs from VMware, VMs from Hyper-V, or physical workloads, not only between sites, but also directly into Azure. Why did we do that? Well, ultimately, we want to use that technology to allow you to migrate those workloads to Azure and run less expensively without capital expenditures, but also to allow you to, should you need to, DR into Azure and fail back. And that's essentially what Azure Site Recovery does for you. I'm going to go to the next slide. A couple of links I want you to know about before I show you any of this technology. First, Azure.com. This is my gateway into Azure. I just go to Azure.com. In the top corner, there's a portal button. I click on it, and I'm into my virtual Azure infrastructure. The other thing to note is here's a link on the bottom that you can search for as well around Azure Site Recovery that gives you all the step-by-step guidance for any of those platforms to replicate it into Azure or between different sites. It's worth, and so I'll demonstrate this technology for you right now, just to give you a feel for how it looks in Azure. And if you have any questions as you go, feel free to type them into the window, and Steve will interrupt me as we go through this. So I'm going to share my desktop real quick. And hopefully you can see this. This is my Azure subscription. I'm logged into an Azure commercial subscription because that's where I work. Azure Government, my Azure Government subscription looks somewhat like this as well. We'll talk about the difference between Azure Government and Azure Commercial in a little bit, but suffice to say for Azure Site Recovery, the technology is identical, except, of course, that you're in one of two U.S. government data centers if you're replicating in. In my setup, of course, I've got my Azure Health services listed here. I'm going to go to something that I've defined called my Recovery Services Vault. This is a service that I've provisioned up within Azure that allows me to have a repository for backups that I might do directly into Azure or via a backup server like Data Protection Manager or the Azure Backup Server. Or, and that's what this stuff at the top is, the backup piece where I'm not doing anything. Or down at the bottom, it allows me to configure and use Azure for Site Recovery, which is essentially all I'm using this vault for and what I'm going to show you today. What we see in the overview page here is I've got 9 items replicating into my Azure Recovery Vault from my house. So my recovery vault I call Kelbley House. And I'm just going to click here so the screen builds. These are all of the virtual machines down at the bottom that I'm actually replicating into Azure. The ones down at the bottom here, this 2008 R2 one, and Red Hat 2003, Debian, another Red Hat 2016, and Hannah Montana Linux. Those are all replicating up from one of my Hyper-V hosts at my house. These two on the top, which are replicating up from something called a host that I've named ASR ARM, are actually coming from a VMware infrastructure. So I'm replicating from, could be physical, VMware and Hyper-V all into the same recovery services vault within Azure, so I can have all of that infrastructure DR into one place. We notice at the top there's an orange notification that says a new mobility service update is available. So it's notifying me that there's an enhanced agent that I could push out to these various virtual machines in my infrastructure if I want to. And this warning on this particular VM virtual machine that I've got is actually digging in and showing me that. What I've done is, as I mentioned, as part of the infrastructure, I've provisioned up a virtual machine in my house on my VMware infrastructure that acts as a catcher, the process server in my VMware world that aggregates all of the transactions from a storage perspective and then writes them up to a scalable web service in Azure securely in an encrypted fashion, but also functions as an endpoint that pushes out updates like this agent to those various virtual machines. And again, the Azure documentation that's available to you is very clear. Here's an example of one of those pages, and I'll go back into the Azure screen in a minute. This is just an example of the walkthrough guidance that was updated 54 minutes, or it on the 23rd of October, but only they give you how much time it takes to actually read. I could read this in all of an hour, and as it goes through, it steps me through all of these steps on how to deploy to replicate from a VMware VM or physical server infrastructure, what my on-premises requirements are, what my Azure requirements are, the types of virtual machines or hosts that are going to be supported going to Azure, including various Linux distributions, how to install agents, various limitations, and then also gives me even graphics that show me the ports that I potentially might need to open, as well as DNS endpoints that I need to be able to get to. It's very straightforward as far as how to do the configuration and set it all up. You can do it in a morning, and I've done it in a morning with various customers. So I mentioned I needed to deploy a virtual machine into Azure, into my home infrastructure. As I go through and provision this up, I'll go through those basic steps, and what it has me do is download the installation package. I provision a virtual machine up in my VMware infrastructure just like I would anywhere else. A 2012 R2 virtual machine to facilitate replication of Windows systems up to Azure. I install VMware's Power CLI, and again, the links and everything are available to me when I go through this. And I install the agent that manages all that process server installation for me. Once I've done all of that, once I have that VM deployed, in order to add new virtual machines to replicate up to Azure, all I really need to do is identify the host that I've configured and connected to my Azure server. And in this case, it's that server I mentioned, the ASR ARM box. I can pick the machine type that I'm going to replicate up. If I specify virtual machine here, it's going to leverage the VMware credentials I've shared with that process server on premises, and it's going to use the VMware Power CLI APIs to go out and discover my VMware infrastructure. I'm going to click virtual machines, and then I can pick from amongst the VMware servers that I've told it about. I'm not super creative. I have 2 ESX servers at my house, ESX and ESX2, and then essentially, if I want to, it's going to pull back all of the lists of virtual machines on those hosts, and then as I click through, it's going to show me the available target systems that it's going to give me more options because I'm going to have to configure the network that I'm going to fail over to, how I'm going to configure the resource group, all the things that I would do as part of building up a VMware or an Azure infrastructure. And I click through, and this is where I select my virtual machines. Any virtual machines that are eligible to replicate up and that it can detect, it's going to show in the list here. Right now, the 2 virtual machines that are left that aren't replicating up in my host infrastructure are ineligible to replicate up because they're powered off. Again, it's worth noting that the Azure Site Recovery software, when I'm replicating up from either a physical box or VMware, requires an agent, and the power state of the virtual machine or physical host must be on. I'm going to actually click back here. I just wanted to show that to you. And I'm going to go back, and I'm going to go look at and turn on and replicate from my other VMware host, where I'm going to show you that I have an eligible virtual machine. But I just wanted to point that out. So I'm going to select ESX2, hit OK, and I'll hit OK again, and then I'll get to the list of virtual machines that are eligible in that infrastructure. And again, this is not, it's using my VMware admin password in that infrastructure to discover these virtual machines, but it's not actually sharing the password with Azure. Okay, so in this case, we see that I've got a bunch of virtual machines powered off, but I do have that process server that's eligible to replicate. If I wanted to replicate it up, although I probably don't because he's the guy who's actually catching all those transactions, I can click on it and hit OK. I'm just going to walk through this process with you, and then we'll abandon it, just to show you how easy it is. Once I've selected the virtual machine, then I have to figure out the account that I'm going to use to inject the agent. We talked about the process server having the ability to go out and discover these virtual machines and then inject the replication agent into it. Well, it's a Windows box, so I'm going to use something I call domain admin. Now, I shared with the process server in my infrastructure my domain admin password because it's my house, and that's cool. You probably wouldn't do that, but the important thing to remember is that password is encrypted and stays on the process server. It doesn't go up to Azure. It's just showing me a display name so I can pick the right credential. If we look back at that pull down, I also had root 1 and root 2. Those are the VMware root passwords for the various VMware hosts I have in my infrastructure at my house, and they're different, so I needed to specify them. Once I've selected the credential, I can select any of the disks that I might want to replicate up. This VM only has 1 disk, so it's only going to let me do all disks. And then the other thing that I need to do is I need to adjust the target name for going into Azure. My target name coming from VMware is ASR Process Server. I can't use that here because Azure doesn't allow for spaces, for example, in my VM name. So I'd have to click on it and just put ASR. See if that'll take. And it does. Then I hit OK. The next step then is where I would select things like my default replication policy. I only have 1 default replication policy defined for Azure Site Recovery, but this is where I can select different recovery point objectives for my virtual machines. How many snapshots do I want to take of the virtual machines or physical machines coming from premises up into Azure might I want? In this case, my default is I'm going to take and create snapshots in Azure so that I can recover any of these systems from a snapshot that happens every 15 minutes. So that means that essentially I have 4 backups an hour in Azure that I can recover to from on-premises, which is fantastic. I also have a recovery point retention threshold, so I'm going to keep recovery points for 24 hours. Should replication fail, I'm going to continue to keep them, but I'm not going to keep them once I have 24 hours worth of good replicas based on the way I've defined my policy longer than that. And then the third item there, app consistent snapshot frequency. This is one of those unique, interesting capabilities that came about in Windows 2003. Microsoft introduced a technology called Volume Shadow Copy Service in Windows Server 2003 that allows you to snapshot a file system. It also allows you to request applications that are VSS or Volume Shadow Copy Service aware to quiesce. So essentially to take a SQL backup and get an application consistent backup of SQL or Active Directory or DHCP or anything that'll participate in the VSS writer-requester process. It works with third-party databases as well. Essentially, Any database that's VSS aware, which would be, for example, Oracle 11G or newer, if you had this set for 60 minutes, every hour when you're replicating up to Azure, you would have application consistent backups running on top of Windows for those database services on top of it. So that's just worthwhile noting. Volume Shadow Copy Service is something that's been built into Windows for 13 years. If you're replicating Linux virtual machines to Azure, it doesn't have an analog to Volume Shadow Copy Service. However, we enhanced the drivers in Azure and in Hyper-V to facilitate file system quiesce in Linux. So we actually quiesce the file system, although we can't get application consistent quiesces as easily in Linux without some scripting. So I could click OK here. I'm not going to do that. I'm actually going to, well, I'll hit OK. Let's see what happens. And enable replication. And then I could hit Enable Replication right here, and it would start replicating up to Azure. I'm not going to do that because, again, the box that I selected is the box that's aggregating all the storage transactions for my VMware infrastructure and writing them up to Azure. It doesn't make a lot of sense to push it up there. So that's great, John. That's fantastic. Azure Site Recovery looks really easy to do something with. How about you fail something over into Azure and show us how easy that is? Okay, that's great. Let's do that. Here's a virtual machine that I'm replicating from my VMware infrastructure, 2008 R2 box. If I want to turn it on in Azure, I've got a couple of options. I can turn on, I can call or declare an unplanned failover for this virtual machine. In the event that a host failed on premises, or I have corruption in a VM, perhaps someone got into a file server and it's been crypto-lockered, right? I could go back to a replica if one's available to me before the issue happened and fire up an unplanned failover. I can also, though, do a test failover. For any of you who've ever been and done a DR failover at a DR provider, you know, you've got to take, it ends up taking a 24-hour period where you pull tapes and you do all sorts of other things. In Azure, to do the same type of thing, I just have to do something as simple as click test failover. And what this actually does is it creates a snapshot of the virtual machine that I can attach to an isolated, separate network and fire it up. It'll totally provision it online. If I were provisioning this VM to go into my production infrastructure for migration, I'd probably put it on my primary production network. But because it's a test failover, I'm going to tell it to go over to my Kelbley test net, and I'm going to hit OK. Oh, and I can also select from a selection of recent snapshots. As I mentioned, if I'm taking 4 snapshots an hour and have application consistent snapshots every hour, I can go through to either the last app consistent or the latest low recovery time objective snapshot that's available to me and recover. Or I can go back custom and select a different one. I'm just going to go for the latest app consistent and hit OK. That's it. The process that needs to happen to make this happen, we see in the top corner, it's starting the test failover of 2008 R2 full. What it's doing now in Azure is it's creating the snapshot. So coming from VMware, where my virtual machine was living as a VMDK file from a storage perspective, it's taking the storage that's tied to it that I've replicated on a per transaction basis up to Azure, and it's creating a VHD file. Very similar, just Hyper-V compatible because that's what's in Azure. It's going to fire up a very small virtual machine tied to that storage once it's set up. It's going to then reach into the virtual machine, disable the VMware drivers that are there, inject appropriate Hyper-V drivers, turn off that virtual machine, then build the VMware similar virtual machine, the one that I had on premises, but do it in Azure with a similar number of network interface cards based on what I've provisioned and the machine size I've selected in Azure, and then turn it on and give me access to it. That process, regardless of the amount of storage used, can take between 5 and 12 minutes is what I see for a VMware virtual machine. Turning on a virtual machine coming from Hyper-V is a lot quicker, and I'll do a test failover for this Windows Server 2003 virtual machine into Azure as well. So I'm going to click test failover for this. And the screen will come up. And we'll do a similar failover as well. So you can see how, and I'll select my test network, hit OK. And we see it's starting to test failover here as well. Now, if I go back, and I'm going to hop around a little bit in the user interface for my Azure infrastructure, I'm going to go to all of my virtual machine, all my resources from an Azure perspective. These are all the things in my virtual data center that are defined. Whoops. I think my audio went again. You guys hear me?
Yeah, we can hear you.
Okay, sorry. It must just be me. Let me go to my virtual machines instead. How about that? Make it a little clearer. So we see that I only have 4 virtual machines that are defined here: a jump box, a domain controller that's stopped, and a VM in India, and this other temporary one. It says it's creating. That's one of the 2 virtual machines that I just asked it to create a test failover of. If I go to refresh, at some point, that's actually going to correspond, once it's done creating, to one of the virtual machines that I just asked to do the test recovery of. It's going to be the 2003 virtual machine because it's coming from a known infrastructure, a Hyper-V infrastructure, where it already has all of the file properly configured and the network infrastructure already properly configured. The VMware one's going to take just a couple minutes longer to get to this process as far as creating it all. I want to bring up one other point and go back, and we'll come back and look at this process once it's done in the Recovery Services Vault. When we look at the various virtual machines that I have in the infrastructure, and I'll click on my Site Recovery Services, I want to make the point that virtual machines that are coming from VMware, like the 2 at the top, have to be compatible with Azure, which is to say that if they're going to be replicating using the InMaj technology, this agented replication, they have to be a 64-bit operating system. And from a Windows perspective, they either have to be Windows Server 2008 or newer, or if they're Linux, they've got to be a supported Linux distribution for going into Azure and to be able to run in Azure. So that's an important DR consideration when going to Azure. The other thing that's worth noting is currently for Azure Site Recovery, the largest volume size that you can replicate into Azure for a virtual machine or physical machine using that agented technology is 1 terabyte. Now, that's an Azure limitation because that's the largest VM volume that we can attach to a virtual machine. If I'm coming from VMware, the rules are a little bit different. The rules for that are essentially anything goes. If it runs on Hyper-V, I can replicate it into Azure. And because within the operating system, I'm replicating, and because I'm replicating not within the VM from an agented perspective, but at the hypervisor level, I actually have the ability to replicate 1 terabyte volumes that are defined in Hyper-V, but can be spanned, using storage spaces within a virtual machine. So I can create multi-terabyte volumes that can be DR'd very easily into Azure. We expect that this 1 gigabyte limitation or 1 terabyte limitation will go away very shortly within Azure for both Azure Site Recovery for VMware and physical boxes and Hyper-V, but it's still a limitation and worth noting right now. So we'll come back and look at the status of those virtual machines failing over. Maybe we'll just do it right now for giggles while we're here. And then we'll get back to the slides because we've got about 20 minutes. Okay, so what we see here now is we have our 2003 R2 Enterprise Edition virtual machine that's running. That was the second one we provisioned up from a DR perspective. So we have a virtual machine running. We see now we've got another virtual machine that is ASR Temp. That's the VMware virtual machine, the 2008 R2 one, that's provisioning up and taking a little bit longer, as I mentioned it would. We can go in and, we can log into these. We can do a variety of things afterwards. But I'm going to go back to the slides right now, and we'll come back to this later if we have any questions. I also wanted to point out, too, that the virtual machine that we're failing over, this 2008 R2 full, is right here running in my VMware infrastructure at my house. So this is my vSphere client at my house. We'll go back to the presentation real quick. go back to our slides. As soon as I figure out how to go back to my slides. There we go. And I want to make a couple of points while the VMs turn on in Azure. Everything I've been showing you is in Azure Commercial. What you're going to want to do when you get into, if you're using Azure Government, and again, if you have compliance reasons, if you're a state and local government customer, you may very well be using Commercial, or you might be using Azure Government, depending on the requirements that you have. It's worth noting that the portal link for getting into Azure Government is going to be portal.azure.us, and you should use that. Azure Site Recovery was first introduced both in the commercial Azure cloud and the government cloud using the older non-Azure Resource Manager classic portal. It's still available there to use in the government portal. Don't use it. Don't go and provision up Azure Site Recovery using manage.windowsazure.us. It doesn't run as effectively, and ultimately, hopefully, it will be deprecated. You want to do it in the ARM portal to make it compatible with future Azure deployments that you may have in Azure Government or Azure Commercial. If you are using Azure Government and the Classic portal and you need to migrate virtual machines up, you can certainly go ahead and use Azure Site Recovery to migrate into that Classic infrastructure and then potentially migrate it into your ARM infrastructure later if you want to. I also wanted to point out that for government customers, there is a 90-day trial that you can get $500 worth of use out of every 30 days. The link is right there. You have to be a government customer. You have to be validated, but it is pretty straightforward. The details may change. Don't hold me to them, but at least that's the information that I have most recently with Azure Government, and I wanted to make that available to you. We'll see if you have any questions or if you have any next steps. You can certainly, again, ping me, shoot me an email, and I'll follow up with you. What I'd like to do is go back and just show you that our virtual machines have failed over. So I'm going to show my desktop again. We'll go back to our Azure infrastructure. I'll hit refresh. And we see that it's deleting the temporary virtual machine that I mentioned to you that's just there for a brief period. For the VMware failovers, we see that our 2003 virtual machine that came from Hyper-V failed over very, very quickly. This one is going to continue to delete for another minute. Then we're going to see it provision up as a 2008 R2 virtual machine, and then we could have access to it. With that, are there any questions that I can address? I know I've been speaking awfully quickly. Go back to the slides, I guess. I can remember how to get back to the slides. Scroll down.
Any questions for John? So, John, I got a question for you that I've heard. So, for folks that are running SQL Server and SQL Server Always On,
right.
How would that factor into what you've just showed us? Should we use the Always On? How does it complement that?
That's a great question. I think that the guidance that should always be followed is if you have an application that is high availability aware or architected for high availability, you should use the application-specific high availability that's in it. So, for example, with SQL Always On, if you want a highly available distributed SQL infrastructure running on premises and Azure, you should use SQL Always On replication between your on-premises infrastructure and Azure. Same thing for Exchange. You should leverage DAG replication if you wanted to, or if you're using it, or Oracle replication. In those instances where you have a standalone database, a SQL Server database, a SQL or Oracle 11g database, it might make sense to use ASR to DR it up because you haven't invested in the HA capabilities of that addition, right? Some databases don't have the ability to replicate because you bought certain things. Another great example is Active Directory, for example. Some people want to use Azure Site Recovery for Active Directory. In order to properly deploy and use Azure with business continuity disaster recovery technology, you need to think of Azure as another data center. If you had a secondary data center that you were putting in place, you wouldn't replicate an Active Directory domain controller to that other location using some third-party technology, you'd simply deploy another domain controller there and let Active Directory replicate as it should. And that's precisely the guidance and thinking that you should use when you talk about DR for Active Directory. First step that you want to do when you build your Site B, build your Azure subscriptions via your Azure enrollment, is going to be thinking about name resolution, DNS, for example, using AD, integrated DNS, and Active Directory replication between those two sites, which then is predicated on having secure networking between those sites. That express route component that I mentioned for high-speed, low-latency direct connection, or a secure site-to-site VPN, whether you leverage the site-to-site VPN technology that Microsoft provides directly to Azure, or you use a third party. We have customers that rely on certain partners, Palo Alto, Cisco, Barracuda, to do site-to-site VPN, even SonicWall. You may want to, between physical sites, why wouldn't you use the same type of technology between here and between Azure and your on-premises infrastructure to facilitate that secure replication? Because that's what your network folks are going to want you to do. So, great question. Putting that infrastructure in and leveraging the application-specific replication and DR capabilities is always a great first step for those other things that don't support it. File servers, web servers that might be stateless. Azure Site Recovery is hands down the best solution. So,
great. Thanks for that. And I got another question here in the IM window from Dutchess County, which is, what versions of ESXi are supported?
That's great. So ESXi 5.5 is supported, 6.0 is supported, but not some of the advanced features. So things like vSAN and some of the interesting new storage capabilities in ESX 6.0 and later aren't supported. But the two ESX hosts I have at my house were 5.5. That's what I was using. It works great. I rebuilt them when my eval licenses expired as 6.0, and it worked fine as well because I'm not using any of those advanced storage features. So it works great with either of those. I haven't tried it with 5.1. If you go up to the ASR documentation, it'll be pretty clear about what you can and can't do with it. The other thing I'd note, and I didn't show it here, was how you fail back. So the process, because that's a really important consideration. When you fail up and you're using VMware in particular, it's pretty simple because you're using an agent in the virtual machine that's writing storage transactions to the process server that then encrypts and compresses them and writes them to the scalable web service that Microsoft has for Azure Site Recovery. When you fail back, you have to reverse that process, but you don't have a scalable web service in your data center. So what you have to do is you have to configure a server that's going to take those storage transactions and talk to VMware and provision up VMDK files to apply those transactions to, right? So that means that you're going to need that site-to-site VPN or express route to have a private connection from your Azure subscription directly back to your data center to be able to apply those storage transactions to fail back. Now, as a Microsoft employee, I'm perfectly fine with you replicating everything to Azure and leaving it there forever. I have likened Azure Site Recovery to the front door of the Hotel California because we want your VMs to come in and never leave if they can. But if you want to use it for the way it's intended for DR, you can certainly replicate them back on premises.
Got it. Thanks. And I think Haley has a question.
Yeah, thanks, Steve. Hey, John, this is awesome. I just have a quick question. I'm not sure if you covered this, but many times I talk to people about this. They'll ask me if there's a way to kind of automate the failover, since in light of a disaster, people may not be, thinking clearly, et cetera.
Sure.
Is there a way to do that with maybe a PowerShell script or?
Well, there is, and that's really a struggle sometimes because what people sometimes liken or want out of their business continuity disaster recovery solution is they want something that's going to function like, and I'm just going to refresh because I'm going to go back to recovery plans. Here we see the 2008 virtual machine is running. They want to have a high availability solution that will automatically fail over. And that's not what you want in a business continuity disaster recovery system, because if you automate failover, bad things could happen. You might have multiple instances of a database running in different places applying transactions and have to unwind that. But you do need, to your point, the ability to recover via a plan. And so what we've done is we've institutionalized something called recovery plans within Azure Site Recovery, where you can build the steps associated with failing over either a particular application or set of servers for an application or an entire data center. And this allows you to build into, and I haven't done a very good job with this, I apologize. You can build into your recovery plan different steps and dependencies, and then also build in scripts and locks from a resource management perspective using Azure Automation, so that if, for example, you wanted to have a recovery plan to bring up your infrastructure, you know that there's certain dependencies you're going to have to bring up an infrastructure in a Site B data center. You're going to need things like name resolution, DNS, right? That's a first step. You're going to need the ability to bring up domain controllers so you have a security infrastructure for people to authenticate against. Then you can bring up your database servers. Then you can bring up your application servers. So you're going to want to bring all those things up. And you can certainly automate all that through the recovery services plan configuration, and you can test the whole process. And what we do is we allow you to tie automation steps using Azure Automation into that should you want a relatively complicated or automated process. But ultimately, you want to use ASR as the big red button in the sky, and you don't want a robot to push the button. You want a human to push the button when you declare a disaster. A little bit unlike clustering, but that's a great question. You can automate it, but it's going to be on a case-by-case basis. So,
thanks so much.
Great question. So now, I'm going to go back to my my recovery services vault real quick, because I did mention about the whole disaster recovery process, and we're running out of time a little bit. Hopefully, we've had some great questions as well. I wanted to show you what our VMs look like right now, because we've had 2 test failovers, right? I now have 2 virtual machines that I'm doing my DR test against, this 2008 R2 and this 2003 Enterprise Edition one, and it says that they're waiting for user input. Well, they're waiting for user input because they want to know the results of my DR test. So what I can do when I go back, here's the details of that particular query or question around the waiting for user input. If I click on the virtual machine rather than the log, I have the ability to clean up my test failover. So this is where I'm done with my DR test. I've logged into the virtual machine if I chose to, and I can tell Azure to just get rid of the test environment. It was a great test. Better than cats. Okay. Test is complete. Delete test failover virtual machine. Hit OK, and it's gonna tear down my test infrastructure. So you can see if I wanted to test an entire application suite, I could do that. Tie it to a virtual machine or a virtual network. Do my application testing, verify that everything was good. I could essentially do a DR test in no time, which is fantastic. The other thing that you can do, which is kind of an ancillary benefit, is I can do a DR test and automate a DR test using PowerShell if I wanted to of a virtual machine I'm replicating into Azure. And then while the VM is provisioned, shut it down, extract the VM, and put it into a test environment. So I could essentially use Azure Site Recovery to do automated test data refresh from production data without all the hassles of other automation tools or the hassles of different components of DR replication or of database replication being tied to it for very complex environments. Again, it would require a little bit of PowerShell and doing some other things, but that's worth noting. The other thing I wanted to point out that I haven't touched on is really the cost associated with this. Azure Site Recovery is Microsoft charges on a per instance basis per month. So to replicate a virtual machine or a physical machine from on-premises up to Azure costs, generally speaking, less than $40 for most of our government customers per month, right? And you must go to a reseller to get the actual cost. That's $40 per virtual machine replicated to Azure. There's also costs associated with storage. If you've looked at Azure storage, you know that out on the azure.com/pricing page for locally redundant storage, it's about $24.50 a month a terabyte. which means that for most virtual machines that I see in people's environments, they're looking at less than $50 a month to DR them into Azure, which is a pretty economical way. That's less than the cost of a tape to do this type of DR and replication into Azure. You don't get the long-term retention per se because of what we showed around the 24-hour retention, or however I have it set up. I can set my retention periods to be longer, but again, you're going to pay for a little bit more if you're keeping multiple copies over a longer period. But that's a pretty economical way to run. Contrast that $50 per VM or $60 per VM per month against what it would cost you to create a Site B, what it would cost you to put a VMware cluster or VMware infrastructure or Hyper-V infrastructure for hardware, the cooling, the electricity, the security, plus the software licenses for VMware online, just to get to the point where you could turn on a single virtual machine. It makes it and again, infrastructure that you hopefully will never use from a business continuity and disaster recovery perspective. This ends up being cost justifiable in virtually every scenario. So with that, I will stop presenting, stop sharing again, and if you have any other questions, happy to jump in and answer them in the next 3 minutes. If not, I hope everybody has a great weekend.
Thanks, John. I think Stephen Hoffman, Stephen, you got just awesome, great job. I agree. John, thank you so much. Any other last-minute questions for John? And it looks like we're good. Hey, thanks, everybody. Appreciate you taking time out on your Friday afternoon. Have a great weekend. Thanks, John. Great job. Appreciate it. Have a great weekend, everybody.
Thank you. Bye-bye.